Alright, so now we're going to talk about specific heat. And what specific heat basically is how likely some object is to change temperature, right? So if we have something that has high specific heat, it's not very likely to change temperature. Versus if we have something with low specific heat, which is more likely to change temperature. So say we have this pizza, right? And essentially there's two parts to this pizza. There's the crust, and then there's the cheese, the sauce, and all the toppings. Now, typically, when I take a pizza out of the oven, and it's all hot and everything, typically the crust is cooler than the sauce, the toppings, and the cheese. And the reason for that is that our crust has a lower specific heat, right? The entire pizza was the same temperature when it was in the oven, but once we took it out, the air around it cooled down the crust faster. And then the cheese, the toppings, and the sauce is hotter because it has a higher specific heat, so that means it's less likely to change temperature, so hotter to touch. So now let's talk about the actual equation we use when solving for specific heat problems. So typically our Q is energy transfer between two items, and this is typically in joules. We've got our C, which is our actual specific heat. Move the board a little bit. And our specific heat is either in joules or calories over grams times degrees Celsius. We've got our mass, M, which is typically in grams. Then this is simply just the mass of the object that we're trying to find the specific heat of, or the energy transfer of. And then we have delta T, which is change in temperature. So that would be T final minus T initial, and it's typically in degrees Celsius. Now, an important thing to note here is our change in temperature. Say if we have a problem where it changes from 10 degrees to 20 degrees, we would do 20 minus 10 degrees, right? But say it was the other way around. Say it was 20 degrees to 10 degrees, right? This kind of tripped me up a little bit when I was learning it back in chemistry, but you always take the second number and subtract the first one. So it's not always going to be a higher number that you subtract. Alright, so just to make that clear. And yeah, so basically this is just an equation relating the specific heat, C, the mass of the substance, M, the temperature change, delta T, and the heat, which is Q. So now let's do an example problem. So let's say we have this here. How much heat is required to raise 70 milliliters of water from 40 degrees Celsius to 60 degrees Celsius if the specific heat of water is 4.18 joules divided by grams times degrees Celsius? So to solve this problem, first we want to figure out what information we have, right? So here I see 70 milliliters, and if we do a quick milliliter to gram conversion, we can figure out that that's going to be our mass. We have 40 to 60 degrees, so we can figure out that that is going to be our delta T. And then it tells us in the problem what the specific heat is, so this is going to be our C. Alright, so now we know all of the elements. Now we can figure out what we're trying to solve for. And in this case, we're solving for our Q. So we set it up. Q equals our C, which is 4.18 joules over grams times degrees Celsius times our mass, which is 70 milliliters, and essentially 70 milliliters is the same thing as 70 grams. It's a simple conversion. And then we have our change in temperature, final minus initial, 60 degrees Celsius minus 40 degrees Celsius. So if we plug that in, we end up getting, I don't know, can you see that? Doesn't matter that much. But we end up getting that our Q equals 5,852. And since we're trying to figure out our units here, we can use the cancel out method, where we basically look at the units within the problem, and then since stuff is on the bottom and on the top, we can just cancel stuff out. Right, so we've got a gram here and a gram here. We've got Celsius, and then essentially this is 20 degrees Celsius, so we just cancel that one out too. So our final unit is joule. So our final answer is 5,852 joules. That is how easy specific heat is. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!